Hey everyone, and welcome. Today we're going to talk about something that's basically running the world behind the scenes, machine learning. We're going to break down the three big ways we teach computers to think, to learn, and to make decisions. And we're going to do it fast.
You stop and think about how your phone can instantly pull up every single picture of your dog, just like that. Or how a streaming service seems to read your mind and knows exactly the movie you're in the mood for. Well, it's not magic, I promise you. It's machine learning. But how does it actually do it?
So here's the secret. It's not just one single thing. The trick is that we've come up with different ways to teach these machines. You can almost think of them as different teaching styles. Today, we're going to look at the three main ones: supervised, unsupervised, and reinforcement learning.
Okay, first up, and the one you'll see most often. It's the most straightforward method, and it's called supervised learning. The best way to get this one is to imagine you're studying for a huge test, but you have the complete answer key right there in front of you. The absolute key here, and you can see it in the definition, is well-labeled data. What does that mean? It means every piece of information we give the machine already has the right answer tagged to it. Now the catch is, creating all this perfectly labeled data can take a ton of time. But the goal isn't for the machine to discover something new. Nope, it's for it to learn the existing patterns so well that it can predict the right answer for new stuff it's never seen before.
In this whole cat and dog analogy, it's perfect, right? If you show a computer thousands of pictures that you've labeled cat and thousands more that you've labeled dog, it starts to pick up on the patterns. It learns what defines a cat, the pointy ears, the whiskers, versus what defines a dog. It is literally learning by example.
So the whole process is pretty simple when you break it down. First, the algorithm just takes in tons of that labeled data. Second, it crunches all of it to find the connections, the hidden patterns. And finally, when you show it a brand new picture, it makes an educated guess based on everything it learned. Yep, based on what I've seen, that's a dog.
Now, inside supervised learning, the machine is usually doing one of two things. The first is called classification. Think of this as sorting things into different buckets. Is this email spam or is it not spam? The second job is regression, and that's all about predicting a specific number, like trying to guess what a house will sell for or forecasting your sales for next quarter.
Okay, that all works great when you've got that perfect answer key. But what happens when you just have a giant, messy pile of data with no labels, no answers at all? How on earth can a machine learn anything from that? Well, that brings us right to our second teaching style, unsupervised learning. With this one, we give the machine zero answers. Instead, we basically tell it to be a detective. We say, here's a mountain of messy data. Go find the hidden patterns all by yourself. The huge difference is right there in the definition. It's trained on unlabeled data. No tags, no answer key. The machine's whole job is to just dive in and see what interesting structures or natural groups it can find. The really cool thing is that sometimes the patterns it finds are totally surprising, things a human might never have noticed.
So what's it actually looking for? Well, a lot of the time, it's trying to do something called clustering, grouping similar things together. For example, it could look at customer data and create different groups based on how people shop, without us ever telling it what groups to look for. Or it can be used to find the odd one out, an anomaly, like a weird, fraudulent transaction that doesn't fit the pattern.
I mean, just think about that for a second. The machine isn't just predicting an answer we already know. It's discovering the inherent structure of the information itself. It's finding the secret organization hidden deep inside the data. That is incredibly powerful. Okay, our third and final method is something else entirely. Imagine you're not giving the machine an answer key, and you're not asking it to find patterns. Instead, you're going to teach it like you teach a dog a new trick, with treats and encouragement. This is reinforcement learning.
So this method comes with some new vocabulary. We have an agent, that's our AI, and this agent lives in an environment. That could be a video game or a simulation or even the real world. The agent just tries stuff. It takes actions. And for every single action, it gets feedback. A reward for a good move and a penalty for a bad one.
It's just this constant loop of trial and error, and more trial. Think about a robot learning to walk. It takes a step and immediately falls over. Oops, penalty. It adjusts its strategy, tries again, and this time stays up for a half second. Hey, reward. Now just imagine that process happening millions of times a second. Over and over, the agent slowly but surely builds a winning strategy based purely on that feedback. And here is the really critical part. The agent isn't just trying to get the next immediate reward. It's learning a long-term strategy, what's called a policy, that will get it the most possible rewards over the long haul. It's learning how to play the long game.
So, there we have it. Learning with an answer key, learning by finding hidden clues, and learning from pure trial and error. Let's put these 3 teaching styles side by side so it's super clear how they all stack up.
This chart really breaks it down nicely. Supervised learning, it needs labeled data, and its whole goal is to predict outcomes. Unsupervised learning, it takes unlabeled data, and its job is to discover patterns. And finally, reinforcement learning, which uses that dynamic feedback loop to learn how to maximize a reward. Different data, different goals. Simple as that.
At the end of the day, it's not like one of these is better than the others. They're just different tools for different jobs. The best one to use all comes down to 2 things. What question are you trying to answer, and what kind of data do you actually have?
And you see this stuff in the real world every single day. That spam filter in your email? That's supervised learning. When a company groups its customers into different marketing segments, that's unsupervised learning. And those AIs that can beat the best chess and Go players in the world, or robots that learn to do complex tasks, that's the magic of reinforcement learning.
So from having all the answers laid out to finding patterns in chaos to just learning from success and failure, these are the fundamental ways we are teaching machines to think. And it really does leave you with a fascinating question, right? We know how to teach them, and the machines, our students, are getting smarter every single day. So the only real question left is, what will we challenge them to learn next?